Hello and welcome to Unit 14 Online Review. You can find a blank version of this on Canvas, and I'm just literally going to go through the problems and just work them out. And I'm going to use an actual calculator as opposed to the emulator. The keystrokes are exactly the same, and it's just easier to use the actual calculator. Okay, the first question says, the table shows the prices for parking at various beaches along the same coastline. Find the mean of the data set. Also find the standard deviation. So I need to find mean and standard deviation. So I'm just going to go over to my data set and I'm going to type those into the calculator. So to type those into the calculator, I'm going to press the stat key, which you should have seen the videos by now. We've done enough of them, but the stat key is there. I'm going to press enter just to edit, and I'm going to type in those values. So 2.5, 3.75, 1.25, 2.25, and 3. Just going to double check I typed them in twice wrong. 2.5, 3.75, 1.25, 3. Okay, you're just going to press Stat, go over to Calc, and then just press Enter, 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 Enter. And it wanted the average, the mean, and the standard deviation. The mean is X bar, so 2.55. So X bar equals 2.55. Standard deviation is that SX, so that's that guy right there, and he is 0.93. And that's it for that guy. Okay, question number 2 says family A and B both have 8 people in their family. The ages of each member are listed. So you have 2 sets of data. These are not one set comparing each other, just family A, family B, they're 2 sets of data. Okay, which family has the greatest or the greater interquartile range? I'm just going to read what I have to do so I can calculate one time. So I've got to find the interquartile range. Also, which statement is correct about the standard deviation? So I need to find the standard deviation for family A and family B. So I can just go ahead and type information in for family A, find the interquartile range, and find standard deviation all at the same time. Okay, so I'm going to go ahead and go to Stat, Edit. I'm just going to type over these things and say 35, 5, 42, 9, 16, 3, 8, and 12. Okay, so there's 8 members apiece, so there they are. I'm going to press Stat, Calc, Enter, 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 Enter. I need to find the interquartile range, and I need to find the standard deviation. So I'm just going to go ahead and write those things down. So standard deviation is going to be 14.4 for this guy. Okay, and then I might as well go ahead and do the interquartile range. To find interquartile range, you just scroll down and you need Q3 minus Q1, so 25.5 minus 6.5. So 25.5 minus 6.5. Interquartile range is 19. So interquartile range is 19. Now I'm going to do the exact same thing for family B and then just compare those two values. So family B, I'm going to go to Stat, Edit, and just type those numbers in. So we got a 1 and a 5 and a 29, 3, 7, 35, 6, and 9. Stat, Calc, Enter, 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 Enter. I'm going to write those things down. The standard deviation, you could write SX or SD, doesn't matter. That is 12.76. So I'm just rounding. So 12.76, or I could have rounded even just 12.8. And then to find the interquartile range, I'm going to scroll down. Q3 is 19, Q1 is 4, 19 minus 4, 15. Interquartile range is 15. So now I have my information that I need. I'm going to go ahead and go over and answer the questions. So which family has the greater interquartile range? Well, 19 is bigger than 15, so family A. Just going to write the letter A. Okay, which statement is correct about the standard deviation? Family A and B have the same deviation. No, one is 14.4, one is 12.76, so no. Family A has a greater. 14.4 is greater than 12.76, so that is true. Let's make sure the other ones are false. Family B has a greater. No, 12.76 is less than 14.4, and there's none information. No, I figured it out by just doing the stat. So the answer is B on that guy. All right, the resting pulse rates were recorded for 16 boys in gym class. Before they exercise, the plot shows the results. So we have a little dot plot over here. Okay, the question says, what is the range of the pulse rates? Well, the range comes from, sorry, my paper's stuck here, the lowest and the highest, and you subtract those two. So 85 minus 79 is 6. The range is 85 minus 79. The max minus the min equals the range. Okay, how many boys had a rate over 81? Well, 81 is here. Over 81 means not including 81. So over 81, well, there's 3 guys that had 82 and 4 that had that and 2 that had this. So 3, 4, 5, 6, 7, 8, 9. 9 boys had a heart rate over, a pulse rate over 81. Okay, I'm sorry. What percent of boys had a pulse rate of at most 80? Well, how many have at most 80? That means including 80. So that's 1, 2, 3, 4, 5, 6. So there's 6 boys. But it said what percent? So percent is part over whole. So how many boys are there total? So if you're trying to figure out a percent, you just take what you have over the total amount. So 6 divided by, well, I don't know how many there are total, so I'm just going to go add. Oh, actually, I do know. It says 16 boys in class, so I don't need to count. There's 16 dots over there. So 6 divided by 16. I'm going to go in my calculator and say 6 divided by 16. That is 0.375. If you multiply by 100, that gives you your percentage, so 37.5% of the boys. Okay, what is the mode of the data? Mode is the number that appears most often, so 80 and 83. It's okay to have more than one mode, so that's perfectly fine. My mode is 80 and 83. Okay, sorry I'm a little off the screen there. All right, the last question here says, draw a box and whisker plot from the data. So a couple of different ways to do this. I'm just going to go ahead and actually make the box and whisker plot in the calculator, and then I'll show you how to do it otherwise. Okay, so here's my data. I want to put this data in my calculator. So I'm going to go ahead and go into Stat and to Edit. I'm just going to type in these numbers. So 79, 79, 80, 80, 80, 80, 80. Nope, no, too many 80s. So there should be 4 80s. I typed in 1, 2, 3, 4. I typed in too many. 81, 82, 82, 82, 83, 83. I should be using both hands. Okay. Okay, so there's 4 of those. 1, 2, 3, 4 of those. And then an 85 and an 85. Okay, I can double check my data is correct because it says there are 16 pieces of data, and I can just look through and see I didn't type anything in incorrectly. There's no like random 8s or 1s or whatever. Okay. You can just go ahead and create your own box and whisker plot, like with data. I'll show you how to do it in the calculator first. So I'm going to go to Second, Stat Plot, so I can turn that on. I'm going to turn it on by pressing Enter. And then I want to get this box and whisker plot right here, so I'm going to press the down arrow key. I'm going to press over until I get to the one that doesn't have dots. I'm going to press Enter. It's going to change this list down here. Okay, and then you just press Zoom 9, and it graphs it automatically. So there's my box and whisker plot. In order to find these numbers, I just press the trace key, and you can press that on your emulator, and just go left and right and find those numbers. So on my paper here, I want to make a box and whisker plot. I need to have a whisker at 79, so I'm just going to put a dot at 79. I need to have a line at 80, and now I can see that it's right here. Like if I'm looking at my calculator, I can see it says 80 for Q1. So 80 is going to be right here. Then scrolling over, I see that the median is 82, so I'm going to put a line at 82. Scrolling over again, Q3 is 83, so I'm going to go over here and put a line at 83. And then scrolling over one more time, 85 is my max. I'm going to put a little dot at 85. I'm going to connect them to have a box and some whiskers. So there's your box and whisker plot. Also, if you're just by hand, hopefully you know by now that this is your minimum, this is your max, this is your Q1, your median, and your Q3. So if you know how to find those numbers, you just go to Stat, Calc, Enter, 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 and you literally go find those numbers. Here's my min, Q1, median, Q3, max, all the exact same numbers I just used, except I just go put them in there myself. So I just used the one, Zoom 9, that they created for me, and it doesn't matter. Both are the same amount of work, and both are pretty easy. All right, the next question says a box and whisker plot represents the scores earned on a science test. A score of 75 on the box and whisker plot refers to what measure of center? Well, I just went over min Q1, median Q3 max, so 75 is the median. Okay, that's terrible handwriting, it's okay. What statement is not true about the box and whisker plot? So given that box and whisker plot, which of these is a false statement? A score of at most 85 represents 75% of the data. A score of at most 85 means 85 or lower. Don't forget each of these little sections is 25% of the data, totaling 100%. So a score of at most 85 actually covers 1, 2, 3 sections. Therefore, that's 75% of the data. So that's correct, which means it's not the right answer because it's a true statement. Okay, 15 represents the interquartile range. Interquartile range comes from Q3 minus Q1. 85 minus 70 is 15. So this is a true statement, therefore not the right answer. A score of at least 70 represents 25% of the data. A score of at least 70 means a score of 70 or higher. Well, 25% of data is only one section. This is covering 1, 2, 3 sections. So it's actually 75% of the data. So a score of at least 70 represents, it should be 75% of the data. This is a false statement, so that is the correct answer. And then 85 represents the 75th percentile. So a score of 85 is Q3, and you can see that is correct. Number 5, the box and whisker plot represents the test results of a math test or math class of 28 students. How many students scored at least a 72? Again, same sort of logic as above. At least 72 means 72 or higher, which means this is 1, 2, 3 sections. So that's actually 75% of the students scored at least a 72. But wants to know the actual number of students, so I'm going to multiply 75% by the number of total students, which is 28. And then don't forget when you're doing a decimal, when you do a percent, you do 0.75 times 28. So my answer is 21 students. 3/4 of those students earned at least a 72. Okay, next question says, what percent of the class is between 88 and 96? Well, between the 88 and 96 is one section, and it just asks for the percent, so not the number, it's just 25%. Okay, question number 6 says, compare the double box and whisker plot to answer each question. Which plot has the greater interquartile range? That is very easy to see. Q3 minus Q1, Q3 minus Q1. You can just see this is a bigger number. Like, you don't even need to look. The interquartile range is the box, so B for sure. What percent of the data in plot A is greater than 70%? So plot A, 70 is the median, which means that 1, 2 sections is greater than, so that's 50%. What percent of the data in plot B is between 40 and 85? Well, 40 to 85, that is 1, 2, 3 sections, so that is 75%. Okay, which statements about the plot is true? The range of plot B is greater than plot A. Well, range is min to max. Plot B is 40 to 100 versus 50 to 100, so that's 60 versus 50. So the range of plot B is greater than plot A, so that's a true statement. Okay, the means of the two data sets are equal. Definitely not. They have the same median, they have different numbers. You really can't actually tell the information from that just by looking at it, but this is going to have a lower value. It's going to pull that average down. So the mean of B is definitely going to be a little bit lower than A, but you can't even tell that really from the box and whiskers. So that's not a true statement. The lower quartile of plot B is less than the lower quartile of plot A. So Q1 of B is lower than Q1 of A. Well, Q1 of B is 60 and Q1 of A is 65, so that's a true statement. And then the last one here is the upper quartiles of the data sets are equal. Upper quartile is 85, upper quartile is 80, so that is not a true statement, so neither of those are true.